Spiders. Yeah, those tiny 8-legged creatures you usually ignore, or maybe even run away from. But believe it or not, these little guys are teaching humans some of the coolest lessons in robotics. Scientists are now creating robots that move, jump, and climb just like spiders, and it's changing technology in ways you wouldn't expect. Picture this: a spider leaps across a wall, lands perfectly on its feet, and spins silk that's stronger than steel. How could humans ever replicate that? Today, we're diving into the fascinating story of how researchers are copying spiders to build super robots that can climb walls, jump over obstacles, and explore spaces humans simply can't reach. This isn't sci-fi, it's real life. Spiders. Most people see them and think creepy, scary, or even dangerous. But the truth is, these tiny 8-legged creatures are some of nature's most incredible engineers. And their bodies are full of secrets that scientists have spent decades trying to understand. Let's start with their legs. Unlike humans, spiders don't rely solely on muscles to move. Instead, they use a combination of muscles and hydraulic pressure. That's right, hydraulic pressure. By pumping fluid into their legs, they can extend them with incredible speed and precision. This is what allows a small jumping spider to leap distances over 50 times its body length and land perfectly on its feet. When engineers finally understood the secret behind spider movement, they faced the next big challenge: building robots that could actually mimic these tiny creatures. At first, this seemed almost impossible. Spiders are light, flexible, and move with incredible precision. How could humans, with motors, sensors, and artificial materials, replicate something that evolution perfected over millions of years? The very first prototypes were, let's just say, clumsy. Imagine a tiny robot with 8 flexible legs, each joint carefully designed to mimic the hydraulic movement of a spider. Some robots could climb walls, while others could jump, but only for a few inches. Engineers discovered that replicating the spider's natural coordination was far harder than just copying its legs. Imagine a tiny robot with 8 flexible legs, each joint carefully designed to mimic the hydraulic movement of a spider. Some robots could climb walls, while others could jump, but only for a few inches. Engineers discovered that replicating the spider's natural coordination was far harder than just copying its legs. The robot had to sense the environment, adjust to vibrations, and calculate every movement instantly, just like the real creature. Here's a story that shows how painstaking this process was. In one lab, a small robot was designed to mimic a jumping spider. The engineers tested it on a small ramp, expecting it to leap across a tiny gap. The robot launched, but it tipped sideways and crashed. They spent weeks adjusting its leg angles, recalibrating sensors, and redesigning the feet. Finally, after dozens of tests, the robot jumped and landed perfectly, just like the spider it was modeled after. The lab erupted in excitement. This was a huge milestone. Spider silk also inspired the engineers. They noticed how spiders use silk not just as webs but as safety lines when jumping. Inspired by this, roboticists designed lightweight cables and tethers for robots, allowing them to explore high or unstable surfaces safely. These tiny innovations made the difference between a robot that could barely move and one that could navigate real-world environments. But it wasn't just about jumping. Some robots were tested on walls and ceilings, climbing vertical glass and pipes. Engineers even experimented with sticky pads and flexible feet, inspired by the tiny hairs on a spider's legs. These hairs help spiders grip smooth surfaces, a simple trick that engineers had overlooked until they studied spiders more closely. Once the robots had these adaptations, they could crawl up walls with surprising stability. Once scientists truly understood how spiders move, they took the next step. They stopped trying to force robots to move like machines and instead decided to copy nature directly. Researchers carefully studied spider legs, joints, and movement patterns. Every step a spider took was analyzed and translated into engineering data. What they found changed the way robots were designed. The first spider-inspired robots looked unusual. They didn't have wheels, they didn't have heavy metal bodies. Instead, they had multiple legs, flexible joints, and lightweight frames, just like real spiders. At first glance, these robots seemed fragile. But once they began moving, the results surprised everyone. Unlike traditional robots that struggle on uneven ground, spider-inspired robots could walk over rubble, climb obstacles, and adjust their balance instantly. Engineers replaced wheels with legs, allowing robots to move step by step instead of rolling blindly forward. Rigid metal parts were replaced with flexible materials that could bend, absorb shock, and recover from impact. This made the robots more durable and better suited for real-world environments. Motors were also redesigned. Instead of relying only on electric motors, some robots used pressure-based systems inspired by the spider's hydraulic movement. This reduced energy use while increasing control and precision. In some advanced experiments, scientists even tested real spider legs to understand their natural mechanics. They discovered that spider legs function almost like ready-made machines, opening and closing through internal pressure. At that moment, spider biology was no longer just inspiration, it became technology. What once sounded like science fiction turned into real engineering, proving that nature had already built some of the smartest machines long before humans ever tried. One of the most important real-world uses is search and rescue. After earthquakes or building collapses, many areas are too dangerous for humans to enter. Traditional robots often fail in these environments because wheels can't move over rubble or tight spaces. Spider-inspired robots are different. With multiple legs and flexible joints, they can crawl through debris, climb over broken structures, and maintain balance on unstable ground. Some are even small enough to enter narrow gaps, helping rescuers locate survivors without risking human lives. These robots are also being tested in military and security operations. Their ability to move quietly and adapt to complex terrain makes them ideal for surveillance in areas where larger machines cannot go. In industrial settings, spider robots are used for inspections. They crawl inside pipelines, power plants, and hazardous machinery to check for damage, corrosion, or leaks, jobs that are dangerous or impossible for humans. As spider-inspired robots proved their value on Earth, scientists began asking a bigger question: what if these machines could explore places humans can't reach at all? One of the most exciting areas is space exploration. On planets like Mars or the Moon, the surface is unpredictable. Sand, rocks, steep slopes, and low gravity make wheeled robots unreliable. Many missions have already struggled because wheels became stuck or lost traction. Even medicine is beginning to explore spider-inspired designs. Researchers are developing tiny robotic systems that move like spiders, with the potential to perform delicate tasks inside the human body. Space agencies are now researching spider-inspired robots for future missions. Some designs focus on climbing vertical surfaces, while others are built to explore underground tunnels where signs of water or life might exist. Back on Earth, the same technology is being tested for deep-sea exploration and extreme environments like volcanoes and icy regions. In places where humans cannot survive, spider robots can continue moving, observing, and collecting data. For a long time, humans believed technology was about control, stronger machines, faster computers, more power, but the story of spider-inspired robots tells us something very different. The future of technology isn't about forcing the world to bend to machines, it's about learning how nature already works. A spider doesn't fight gravity, it doesn't overpower its environment, it adapts, and that single idea is now shaping the next generation of robotics. Scientists didn't invent a new movement. They discovered one that already existed, perfected over millions of years. What we call advanced technology today is often just borrowed intelligence from nature. Spiders, ants, birds, and creatures we rarely notice are quietly carrying solutions to problems humans are still trying to solve. The question is no longer whether nature inspires technology.
If you enjoyed this video, hit the like button, subscribe to the channel, and drop a comment below. Share this video so more people can see it,